Continuing with our summer review packet for Calculus AB, let's look on page 4, dealing with asymptotes. Excuse me, we've got a definition you can see at the top of the screen. Given the rational function capital R of x is p of x all over q of x, two polynomials, if that ratio is in lowest terms, if you could not cancel anything else out, then we would say x equals r is a vertical asymptote if q of r equals 0. In other words, where this denominator were to equal 0, whatever x value would achieve that, the line x equals r would be a vertical line, a vertical asymptote. You, of course, will notice we're saying if we're in lowest terms. We'll speak a little bit later as to what would happen if perchance it was not in lowest terms, and if in fact a factor might in fact cancel out of the top and the bottom, what exactly would occur. It's not necessarily a vertical asymptote, as we'll see very soon. Also, right here, let's just say that our numerator was of the form a sub n x to the n, and then plus a sub n minus 1, x to the n minus 1, and so forth. We'll look at our leading coefficients right here. Down below we'll have b sub n times x to the m, and of course that n and m very well could be different values. We would say that if that power up on top, if n is going to be less than the leading denominator down below, the degree of that denominator, the highest power down below m. If n is less than m, then y equals 0 is a horizontal asymptote. Horizontal line always will have the form y equals some number. If n were to equal m, if n is going to equal m, then y equals a sub n divided by b sub n, or b sub m I should say down there, that is an m, is a horizontal asymptote. In other words, we'd see that the coefficient of the highest power of x up on top divided by the coefficient of the highest power of x down below, that will create a fraction, and that would be a horizontal asymptote. This is going way back to the rational function unit. Let's very quickly find any vertical or horizontal asymptotes. Right now you might have noticed also that we have avoided having the highest power up on top being greater than the highest power down below. That's a very special case. We're not going to see that on our summer packet. We'll talk about it later in the year though. But find the vertical horizontal asymptotes of, let's say for example 1, y equals x minus 5 all over x squared minus 9. Now if we had that, you of course could factor the bottom into x plus 3 times x minus 3. And very, very, very quickly, as you're looking at that denominator, we could set x plus 3 times x minus 3 equal to 0, setting each of those factors equal to 0. And as we'd solve, we would get x equals negative 3, x equals positive 3. Add a 3, subtract a 3. These are the equations of our vertical asymptotes. There are two of them. I want to point out that neither x plus 3 nor x minus 3 would be canceled out up on top, or in lowest terms, in other words. If it were to cancel out, that would actually become a whole, a removable discontinuity, and we'll talk about that in a little more detail. But real quickly, let's continue working on And using these guidelines about the horizontal asymptote, look, up on top, the highest power of the numerator is a 1. The highest power down below is a 2. So what we're getting at is this little guideline that I talked about earlier, that if that highest power up above is smaller than the highest power down below, then y equals 0 is going to be our horizontal asymptote. And that makes for a very quick problem, and it does occur quite frequently, and it's nice to see that. And that's all you'd be asked to have. Now, real quickly, let's take a look at another problem. Let's take a look at, say, example 2, finding asymptotes of something that might be a tad more involved. Let's say, for example, that we had y is equal to x squared minus 25 all over x squared minus 3x plus 2. Now, a good mantra to have here is to factor first. You could even factor up on top. I strongly recommend that as well. Up on top, you get x plus 5, x minus 5. Down below, well, you'd have to add to negative 3. You'd have to multiply to a 2. Let's try a 2 and a 1. That's the only way you can really multiply to a 2. Choose both of these to be negative. And very quickly you would see that you do in fact add to negative 3x, negative 2x, and negative 1x. You multiply to a positive 2. Now what you're going to notice is very quickly this, that your denominator has these two factors. You're saying now whatever would make this equal to 0, and of course again we're noticing this is reduced. We don't have any extra terms canceling out, but you have x is equal to 1 as you solve here. Add a 2 and you'd get x is equal to 2. And that is our vertical asymptotes. These are vertical lines that our graph will not touch, but will get very, very close to. How about for our horizontal asymptote? Well, here it's a little bit different. And, what I want to point out to you real quickly is that the highest power, oops, didn't want that to happen right there, blocking it out. But the highest power is going to be a 2 up on top. And it's also a 2 down below. So you can see the highest powers are the same on the top and the bottom. There's a 1 out in front. So really just take this one and take this one. We're going to say y is equal to just 1 all over 1. It's just the coefficients. You get this fraction made here. This would be the horizontal line that we would get closer and closer to. So it's not y equals 0 when the powers on the highest power on the top and the bottom are actually the same. All right, let's do one last problem and see if this might help us out. For example 3, maybe the most involved of them all. And this is definitely, you can see very quickly, a lot more involved than our last problem. We've got, a third power down below. Let's go ahead and see just what we could do. Factoring the top, I'm going to do this quickly. You'd obviously be adding to a 5, multiplying to a 4. Knowing that you need to add to a 5, you wouldn't want to have a 2 and a 2. Let's try a 4 and a 1 and make them both positive. Now down below, I do want to make a little side note real quickly. First, always ask yourself if you could factor out a greatest common factor. If there's something that is in common to all three. And there's an x. So I can factor that out. And then what follows next? Well, we'd have to add to a 7 multiplied to a 12. Well, my goodness. I think you see what's about to happen. Yes, we'd have x plus 4 and x plus 3, but this begs the question then, do we just look at the denominator and simply set all of those factors equal to 0? Actually, look, this fraction is not in simplified form. The x plus 4's would cancel out. That means we're not going to have a vertical asymptote with the factor of x plus 4. We're going to talk more about that in just a moment. But of course, we'd have x times x plus 3 would equal 0. That would mean x would equal 0. X plus 3 could equal 0. Subtract a 3, and we have x is equal to negative 3. X is equal to 0. Here are our two vertical asymptotes. X equals 0. X equals negative 3. Well, you know what? We've talked a lot about horizontal asymptotes too, and I'm not brushing aside that x plus 4 issue. We're going to come back to it in just a moment. But just talking about that issue with the horizontal asymptote, notice that the highest power up on top was 2, x squared. Down below we have x to the third. Now we said before that when the top's power is smaller than the denominator's highest power, we're just going to plain and simply have y equals 0 for a horizontal asymptote. So that's beautiful, that's nice and simple, and that's wonderful. There is this other issue though. You can say, what on earth is going on with that x plus 4? And we have what's known as a removable discontinuity, also known as a hole. And that's going to be, now of course you look down here and you'd think, now wait a minute, x plus 4, if I set that equal to 0, wouldn't I get x equals negative 4? It's very tempting to think that we're going to have x equals negative 4 for a vertical asymptote. We won't. What we are seeing, however, is because this x plus 4 would cancel out, we were to just continue writing up on top here, we have this x plus 1 all over x times x plus 3. We get something very, very, very interesting. We can say plug x equals negative 4 into this simplified fraction. By the way, in calculus, we do this notation sometimes. We put a little vertical bar. We'd say x equals negative 4, and that means plug in that x value into this expression. So that would become negative 4 plus 1 up on top. Down below we have negative 4 times negative 4 plus 3. Well, what do we get up on top? Negative 4 plus 1 is negative 3. Down below, negative 4 plus 3 is negative 1, so that's negative 4 times negative 1. And negative 4 times negative 1, of course, is just going to get you a positive 4. So you'd get negative 3 up on top and a positive 4. That's what your y value would equal on that hole, on that removable discontinuity. Now on our summer packet, we don't even ask you to find the removable discontinuity, but it's well worth talking about. There is a problem on your packet where that canceling will take place. And you have to be very, very careful. You can't just look at that denominator and say, oh, set every factor equal to 0. Not if the factors cancel out like it does with x plus 4. So it's a lot to review, a lot for you to think about, but that's why we're giving that to you real quickly. We've got just a tiny bit of time left, and I did just want to give one super fast last problem. What if I would have given you something like this, and if I said, what's the horizontal asymptote? Well, I hope you could look at this and say, well, wow, the highest power up above is a 3, the highest power down below is a 3. Very plain and simply, the coefficients, the numbers out in front of those highest powers, would be what would be used. How would we find the vertical asymptote? Well, in this regard, we'd have to set that denominator equal to 0 and solve. but I'll leave that to you. Next video coming up, even